Good morning. Just to introduce Mr. Paul Ledge, he's the founder, managing director of Thermoguard. We do fire protection paints. It's a bit unorthodox the way we're going to do this today. Paul's, before the pandemic, Paul used to go on the engineering and building engineering annual conferences and experiment from PowerPoint, death by PowerPoint at least, and we used to do quite well at it. And we used to get asked quite a lot of questions during these seminars. So today what we're going to try and do is I'm going to ask Paul some questions and hopefully he's going to answer them. Yeah. So going back a few years, Paul, back when you were working in the paint industry and setting everything off, what worried you during the visits to government direct works painting departments in the 1970s?
Apprentice painters who were burning out paint kettles after using flame retardant paint, ending up being carted off to hospital in a hurry, having been overcome by toxic fumes.
And when you started looking into making flame retardant paint, what did you learn from the antimony salesman?
That it worked by activating a gas to extinguish a flame. Unfortunately, that gas was toxic. And it could, though, also be used as a white pigment, which was helpful because it meant it was very cheap to make, but ultimately not something that I was going to prioritise.
So it's a dual action type of thing.
Correct.
So going back, same sort of time, there was a publication in the Lancet that related antimony and polyvinyl mattress covers becoming cot deaths. Can you tell us about that?
Yeah. As I was developing the flame retardant paints, this actually broke and the news and the causes of it were being released. And they found that when they were washing the PVC mattresses, it released, activated the antimony, which is a catalyst. That catalyst then caused the gas donor within the product, within the vinyl thing, to actually release, and it was killing babies. They worked it out because it found that the blood contained excessive levels of antimony. It was the only method that anyone could work out, possibly got there.
So antimony is in normal emulsions around that time?
Yes, they were, because they were used as a white pigment at that time.
And the release of toxic gas, maybe was it a fire?
Nothing like as much as in flame retardant paint, but designed to be honest. But nonetheless, it does do so.
And over time, would it be grey or?
No, once it's there, you can sort of them out. It's not a terminal issue, this, because you can sort it out by controlling the emission with an effective smoke and gas control paint. There are chemicals that can do that. They're readily available. There is no shortage of them. They're not cheap, but they generally won't do the job.
So, what would stop that? The coat of
The smoke and flame retardant paint, what you've got is you have different kind of catalyst which is not toxic, and that works with a water donor which actually oozes water vapor. We call it vapor, it's not shouting out like a sprinkler, it's oozing out and it's saturating the surface of the paint in order to control the flame spread. Well, then the secondary product, if it's a serious risk surface that we're dealing with, then expands to insulate the surface. Not needed on most cases, but about 20% of the jobs where the particular risk of historic paint mixes, you need that as well, and that's then gives you a permanent barrier.
So you didn't copy and rely on others' antimony?
No.
And so you commissioned chemists?
Yeah, I'm not a chemist myself. I was actually just a specification salesman, interested in what made things work and problem solving and how to help people achieve what they wanted to achieve. And I saw what was going on I decided that there had to be something. You looked around the world, found the chemicals, put them together, and then talked to chemists who can make real paint, who are specialists in the job, and just said to them, focus on doing the job, not on cost.
So, when did the MSDS sheets change for gas release flame retardant paint? Changed to a less toxic gas?
May 2017.
And how much less toxic is that today?
We don't know for sure. It will be less toxic, but it's hard to say precisely how much. I think what I would suggest actually is we could always find out by asking the directors of the stuff that make the stuff to try it on themselves.
So going back to the 70s and 80s, what worried you when visiting the painting contractors?
When you went to their stores, there was an extraordinary amount of flame retardant, but not flame retardant, much as base coats for fire protection systems on their shelves. And it was completely out of proportion to the work that they were doing. When you talk to them, sorry, you can ask me.
They explain why.
Yes, they did. Yeah. So when you asked them what it was all about, they said, well, they've got these products to apply. Specifiers had looked at the brochures and leaflets, and it looked like you put one coat of the base coat product on. And the painters then priced for one product, so everyone put in their budgets for the single coat of base coat. But then when you came to buy the stuff, they found they were forced to buy about 3 times as much as you could possibly get on one coat, regardless of how much you tried. So you ended up with this awkward situation where the painter would have to go back to the specifier and say, I need 3 times as much money, and there's nothing in the budget for it, and so on. It all became an awful fudge.
So what was the spread rate for the 2.5 litre?
Well, the spreading rate was 2.5 square metres to a litre. A good coat of paint is 10 square metres to a litre. I defy anyone to get 2.5 square metres per litre coverage and anything other than you put it on with a yard room.
That's really thick. How did the big paint manufacturers respond to complaints about the thick paint?
Just wasn't their problem.
Yeah. So, going back to your chemist, what remit did you set the paint chemist about texture and depth?
Well, I told it to ram as much of the ingredients that do the most work into the stuff, concentrate it, so you could actually get the darn stuff on in a single coat and make it look like normal paint with a smooth finish, like you've just decorated something, you've not created a texture.
So, when you chemist developed the wood protection paints that you wanted, why did you jump to the BSEN standards?
That was just coming in at that time, and obviously I've been involved calling on the fire test laboratories and seeing what happened with the fire tests and the results of them, which were concerning to someone who is in my position. And I then saw the new standards. The government, the Office of Deputy Prime Minister, issued a bulletin to manufacturers saying they wanted the new standard because it was an awful lot better, and it was. In truth, you can see comparative results. It's between 2 and 3 times safer as a standard than Class O in terms of fire intensity.
And how many coats do we need for the universal compliance for Class B S1DO?
Depends upon the surface. If you've got lots of coats of just acrylics and vinyl paints, 1 coat of paint will do it in one product. If you've got the worst cases, 1 coat of, in the worst cases, mixtures of oil-based and water-based paints or anti-graffiti, because the mixture of different types of paint that causes the problem. When they react differently in a fire, that causes delamination. That delamination causes the delaminating paint to catch fire and spread fire rapidly down a corridor. And so we just went for 1 of each. 1 of the insulating base coat I mentioned to you, and 1 of the water vapour coating, so that we've got 1 of each.
And that, just to confirm, that's all the multi-layers of paint all
We
the time?
we'd heard, and there was a discussion been going on about whether 10 coats was some kind of limit. And there may be for some other products because of the limitations. But for products to achieve a result on the Class B, it's such an intense test that you need something that really does do a lot. And we found, we kept on going, and we found that actually we could get on between 18 and 24 coats of, we could protect between 18 and 24 coats of paint of any mixtures, regardless of what those mixtures were. They were actually paints that we applied to walls internally over the last 50 years.
So, Paul, what struck you when was in the ESEN fire test?
Have we got the video to show you?
Behind the first one.
Do that. This here is actually the secondary test, which is quite useful to use. This is the one which is for what's called part 6. You'll see that after it's been going actually for a couple of minutes, the first 2 minutes no smoke or gas comes out off the surfaces. It's gas fired, so there's no smoke or gas coming from the heat source. But after 2 minutes, we've got gas and smoke coming out from the top. It was really sort of disconcerting to say the least.
So so you obviously weren't impressed by the test for the old Class O?
My concern was that when they developed the Class O standard, they completely omitted top gas emissions from the standard. They want a test for measuring the emissions of smoke and gas, but they just never put it in the standard.
Would you like something to do?
Please. Now here we have the flames curve from the Class O test. You'll see that the actual heat source is a very intense electric radiator, but it doesn't generate any kind of airflow. You'll see the flame which starts on the left-hand side, the actual surface there with the unprotected paint on it, there's caught fire quite rapidly and spread, but then it sort of peters out. And the reason it's petering out is because that is not creating any kind of airflow at all. If you've got wood can, if there's enough of it, generate its own airflows because it's sucking air in order to fuel the fire. But if you've got a surface felt with a flame from paint, it can spread the flame quickly, but it's not creating the intensity of fire in such a way as to suck it and create its own airflows. So, but what you do get on the escape route is when there's a fire, people are opening doors, they're trying to escape. There's going to be whatever is causing the fire, the other source, is going to be causing an airflow through the corridor. So it's vital if you have protection, it's not going to be blown away from the surface. It has to stay on the surface or it's utterly useless. I would say one last thing, beg your pardon, but you may also see it again with that test, the smoke coming off it. So it's building regulators in November 22, and then they were shouting at me, so I jumped out of the line and he does shout at me.
Because it's all the time.
Yeah. But they pointed out in the building in the first section of the building regulations, November 22, that smoke and gas are the biggest killers in a fire. We just can't carry on ignoring it.
Would you like another video?
Please. This here is the new test. You'll see at the bottom you've actually got a heat source with flame. It's actually then blowing with the gas jets, blowing flame at the surface. It's creating the kind of intensity that you actually get in a fire. So, when you're measuring results of performance, you're actually replicating a real fire. The other thing with that test is that it has at the top of it a hood. That hood takes in gas, the smoke, and measures it to measure the emission of that. Whenever you see or anyone refers to having had a result for a Class B, they may say the test includes for testing smoke. It does. But in actual fact, when you get the fire test report, and we will send everyone that wants it, we'll send you a copy of a typical fire test report, you'll see that it explains very clearly what the standards are, what the results are, and it will then show you that actually it's measuring all of these things on the report. So when you get your Class B test, that one, with exactly the same test, give you the amount of smoke being given off. You cannot get that fire test report without them being linked. And the other one is flaming droplets.
So what are the most lethal?
In terms of reaction to fire, the heat intensity and so on, there's F, so on and so forth. E, which is really serious. D is unprotected wood. And then you go to AB, which bizarrely the same surface reactions. A is only for actual substrates. It's not a test that you carry out for surface reactions of fire. It causes a bit of confusion in certain quarters. You've then got, for smoke, the safest one is S1. The most dangerous is S3. I'm afraid so many people at the wrong end of the stick, and anyone that did get the wrong end of the stick, they can be excused. It's not their fault. Just the way the thing was written, but the way that it was written was not. It wasn't a mistake of the people who are writing the building regulations. There is a way that they have to write them. And if you accept Class O, which they weren't led to believe they had to carry on with, for reasons. Move on, yeah. If you believe that you had no option but to carry on with Class O, you couldn't actually then have put, quote, because they wanted Class B, because that's 3 times safer than Class A, heating test point of view. If they had said they wanted the safe smoke, which is S1, and or the safe flaming droplets, which is none, which is DO, if they've done that, then any manufacturer who got B, S2 or B3, and so on, any of those other things like those gold standards, then they wouldn't have been discounted unfairly for having a safer paint than one which didn't do any more than the other, but it looked like it might be worse. So they had to have the equivalent of Class O. Class O, I'm afraid, is unlimited smoke, unlimited flaming droplets, and indeed, Class O paints, that's exactly what they create. S3, D2. Why not? Now this here is when it started. So this is our guide. We were on Megastructures channel, came to our buildings, and we actually set this thing up for them. It wants us to give a demonstration of how this stuff works and what difference it does. It had our intumescent paint on it, and you see on the test the far side one. That's unprotected wood. You've then got, on the middle one, you've got it with emulsion paint, because some people think that water-based paint is going to protect the wood, but once the water's away from it, it's gone. There's nothing in it to create more water, it's gone. So it then burns through as well. And on the left-hand side, well, on my left, I think it might be yours, the near side is the one with our intumescent pitch, and you can see it's expanding, because the catalyst in that, which again is a safe one, is causing a gas internally. It only is internal, it does not expand, it's not a toxic one. And that one causes an expansion of a char layer. And that char forming layer then creates this insulation, which you can see there. This is our technical guys at Rummy, because that's almost incomprehensible. So and you got me talking to instead. A good guy, but difficult to understand. Now, you can see here now, there's actually, as it burned through, on this side here, we show the fronts of them. Oh, sorry, beg your pardon. So anyway, so what we've got here now, if you measure the incandescent layer, you see the flame was burning through the back of the unprotected boards, and then the board that actually we were protecting got 45 minutes now, with obviously a very intense burner, which is sufficient to burn clean through the others between 5 and 10 minutes. Here, at 45 minutes, he's going to put his hand, he wipes his hand over the back of it and ask him to, I wasn't there, but he just chose to do it, fair play. And so he was, even with the burner still on the front, he's wiping the back of it to show that actually you can still wipe the back of it, there's no burn through. Now what he's then going to do is show you from the front. There's a Channel 5 megastructures program, put this on there, one for building for disaster. This was the one to deal with the problems that have been in the Bradford football primary disaster, to show what was available and could be done to prevent the kind of devastating events that happened when wood was burned in that wooden stand. What he's now going to do, he's going to show you the actual, what happened to the surface of the wood, so you can see how much burn through what there was on ours after 45 minutes. So there has been some, it's about 2 to 3 minutes. About 3 minutes, sorry?
2 to 3 mil.
2 to 3 mil we lose when we do a test to the British standard for fire resistance in a fire test laboratory for 30 or 60 minutes with a BS 476 Part 21 test, 22 test, we end up losing 3 mil. And whereas unprotected wood loses somewhere near 25 mil in the same period of time. And that is from something that's looking like paint. It's not looking like artex.
So, we tested originally on 18 to 24 coats of paint. Why so many?
As I mentioned before, there was this suspicion that some people had that there might be a 10-coat limit, and there were comments that there would be a 10-coat limit, so there's a belief that actually once you've reached 10 you have to remove everything because it can't be protected. Well, some Class O paints can't because they don't have to achieve much to pass those tests. If you've got something that has to pass the SEN test, it's got to be so effective that actually there's almost no limit. Even at 20 odd coats, as you'll see if you get our fire test reports for those, and you'll also be welcome to have a copy of our one for softwood, which showing the same kind of results and performance on wood. So it's very clear as to exactly what has been achieved. It's the same paint. The only difference between what we sell for wood and for multi-layer painted walls is that we make it a bit cheaper for the walls, which are much bigger areas. We're not spending as much time on the jobs, and so much more cost efficient for us, more effective. We give it a greater spread rate, doesn't need it to go on. It's not going on telly if it's not off, it can go on even really just like a normal coat of paint applied normally. But the end result is that by putting enough stuff in it, it'll do the job.
So, after developing the wall coats, smoke and flame retardant system, why was 8 years lost applying paint to test panels instead of simply copying the brands?
we found that there two tests was being carried out for Class O. The one that related to their 2 coats of their finished flame retardant paints, which represents around about 80% of all jobs that are carried out. The test panels for that, everyone carried out with one type of paint. It was either one kind of emulsion, one kind of oil-based eggshell paint, but that doesn't actually represent what was found to be the risk. So in actual fact, in the 1980s, I've been in the game quite a long time, companies which were making normal paint were saying, well, hang on, 10 coats of our normal paint, 10 coats of our eggshell, or 10 coats of our emulsion paint, also get Class O. Why do you need that stuff? Which is a perfectly good and legitimate argument. The problem is that actually you don't get one kind of paint from one manufacturer, from one kind of vinyl, one kind of resin over and over again. You get mixtures. And it's those combinations that create this differential performance in the fire, which creates the delamination effect. So that isn't actually the risk. So there's no much point from our point of view. We're a certifying company. Our background is from certifying to meet building regulations approvals, and in those situations you've got to be sure that what you do and sell will do the job. In terms of the other end of the scale, we found that there was a test which was very effective in terms of creating a very rapid flame spread, which was developed for the government, but it was developed in the 70s and early 80s, and that one well replicated the risk at that time, which was multiple layers of different kinds of oil-based paints. Now the problem is that since about 1980, the majority of paints have been water-based. There are some oil-based and sometimes anti-graffiti coatings, and also some oil-based paintings that oil-based paints are still left on from before. But the fact is that if you, as a certifying company, you can't certify something's going to work if you're testing on a surface that's not relevant to what's on the buildings. So we had to replicate that, and in order to create, I think first of all we found that you needed time for the coats to age between applications. So you put 2 coats on, let them age, and then another 2 coats, let them age. And it's that also increases the risk of the delamination. If you were to put coats on in a matter of days, you will not create the same kind of risk. It's very convenient to produce with testing boards, but I'm afraid that's not the issue. The issue is, will it work in the fire? Is it representative of the real world? And real world is what it's all about, not just some kind of theoretical compliance. I could have made an absolute fortune for my family, done all right for them, but I could have made a fortune by making Class O, because you don't need to do much with it. Cheapest chips to make, good money, no risk. If you're a manufacturer of Class O and there's a fire, you point at the test standard. There was airflow in that fire. We passed the test. Not our fault if the test is nonsensical. And if they're being killed by toxic gas and smoke, not our problem. That's not us.
So Paul, going back, why has it been an uphill battle for Class S1D or fire paints to be accepted for multi-layer paints and walls and ceilings?
For the reason I explained earlier, the building regulators really had no option. They were led to believe that you couldn't actually achieve protection in protect surfaces to be S1DO. Well, we were doing it with wood, so there was clearly a lot of logic in that. And when they were told that, they were thinking that they were really stuck with Class O for another 6 years. They've already been given 6 years notice and another 6, they're still being told. Well, what they then do is, because they think, well, they're still stuck with it, they must have some degree of fire protection. They can't go backwards in time and give it nothing. So what they ended up doing was having to accept the standard which was in line with the Class O, which I mentioned to you. They still wanted B rather than O because they didn't want O. But if they had to keep O, they wanted to have this, they had to have an equivalence in terms of smoke and flaming droplets. So they had to actually write into the standard that they would accept as compliant. It wasn't what they wanted, but it was compliant. It was S3D2. So what we had then was, unfortunately, the sales guys, and it wasn't their fault, normal decent guys, but they were only told, they can only tell the people in the housing associations and the authorities what they've been told. They were only shown snippets. This bit, you can use Class O, but not being told that we don't want Class O, but if you know you've got choice, use it. BS3D2, they were never told. People, they've come to us, we've ended up employing people from the companies that make Class O paints. When they come to us, they haven't a clue. They've been calling on customers and advising them for 20 years. They have no clue. What you've then got is a situation where, at the end, we found, of course, understandably, specifiers had been given to understand that they needed S3 and D2. So when they see our stuff, which is BS1DO, they're saying, well, we don't want that. That can't be good.
So now we've created our safety paint. How did your ideas prevent ordinary errors in application? Help the contractors do the correct work?
It's important that we remove the profit motive from under purchase for jobs, and it's important also that we encourage the painters to apply the right amount and to understand what they're doing with it. So we sell the stuff in square metre cans. So we'll say this can does 25, 50 or 100 square metres, rather than having to work out what the spread rate is and what the litres are and multiply it all out and stuff like that. We also found that by doing that, it meant that if a painting contractor would realise when pricing for our stuff that it would have to buy the right amount of gear, they couldn't buy only a bit of it. Because actually, when they ask for a certificate, our certificates are area specific. It does not say we certify that someone's bought some of our paint, and if we want to pass a test, whether that test is good or not. What we do is we say we require the painters to buy the right amount of gear for the surface. They then can't sell it anywhere else, they can't use it anywhere else, they can't even, it'll cost them money to dispose of it. So it's in their own interest to put the stuff on. And by only having one coat of each, and having a slight differential look between the coats, it means they can have to put the stuff on properly. It's automatically leading them to put it on properly. And we carry out training courses for people, because sadly, when it comes to high-grade acrylic paints, there's a need for some training out there. So actually what we do is, the larger contractors, we run these symposiums with our guys, showing people how to put the stuff on. And we've done those for government bodies, and the painting contractors are all blown away with what you can do, and they suddenly realise that they've been doing things they've learned since the end of apprenticeship schemes, which were so good. Since that, we've really had people learning from the old one guy after another. If you've got something when people were learning how to use vinyl matte emulsions, it's not the same technique for a high-grade acrylic paint, completely different.
I think that's what we've got time for.
Right, I'm sorry to have rattled on, What we will do is send you our other stuff that we're going to cover, and also if you'd like to come to see us, anyone that does. And after that, we'll be sending people any other questions that come to our table, which people might be interested people, so that you know where we are in terms of how we can answer your problems and make your people safe.
Thank you very much.